Welcome back, everybody, for another deep dive. And today we're going to tackle a question that has probably crossed all of your minds at some point. I know it's crossed mine.
Oh, yeah.
How do we know how old the Earth is?
Yeah, that's a great question.
Yeah.
And it's a really fascinating story, and one that I think a lot of people will find surprising because, as we'll find out, it wasn't just about figuring out the age of the Earth. It accidentally revealed a hidden threat to human health that we're still dealing with today.
That's right. We are talking about lead.
Lead.
You know that stuff we tell our kids to stay away from?
Right.
Well, this story is way bigger than just peeling paint.
Yeah.
It touches on the history of cars and scientific discoveries and even the air we breathe.
Yeah, it really is a story that highlights how the pursuit of one scientific question can unearth all these unexpected and impactful truths about the world around us.
Okay, so let's paint a picture here.
Okay.
It's the 1940s. We've got this brilliant young scientist, Clair Patterson, just finished working on the Manhattan Project. And now he's obsessed with figuring out the age of the Earth.
It's a pretty big question.
Yeah, it's a pretty big question. And he's an expert in this technique called mass spectrometry.
Right.
And he has this groundbreaking idea to use it on these tiny, tiny ancient crystals
Oh.
called zircons.
Now, zircon crystals, they're pretty special for this kind of work. They form with uranium, but no lead. So any lead you find in them must have come from the radioactive decay of that uranium over millions, even billions of years.
Oh, wow.
By measuring the ratio of uranium to lead, you can calculate the age of the crystal and by extension get a pretty good idea of how old the Earth is.
That's some seriously clever science.
Yeah.
But here's where things take a bit of an unexpected turn.
Okay.
Patterson sets up his lab. He meticulously prepares his samples and starts taking measurements. And that's when he hits a snag.
What happened?
Well, he starts finding lead contamination everywhere.
Everywhere.
Everywhere. It's in his lab, in his equipment, even in the air. And this contamination is throwing off his measurements, making it impossible to get an accurate age for the Earth.
So this unexpected obstacle actually led to a major breakthrough in scientific methodology.
Really? So how did he fix it?
Well, he became obsessed with eliminating every possible source of lead contamination.
Oh, wow.
He scrubbed his lab from top to bottom, developed new techniques for purifying his samples, and essentially pioneered the concept of a clean room environment,
Okay.
which is now standard practice in many scientific fields.
Oh, talk about dedication.
Yeah,
But this also raises the question, where was all of this extra lead coming from in the first place?
that's the million-dollar question.
And this is where the story takes a surprising detour into the history of cars.
The history of cars. Okay,
I'm intrigued.
buckle up because this is where things get really interesting.
Okay.
So the early 20th century saw this massive boom in the automobile industry. People wanted more powerful cars, but the old hand crank starters were notoriously dangerous.
Oh, yeah, I've heard those stories. Oh, they're not fun. And there was even a tragic incident involving the death of Byron Carter, a friend of Cadillac founder Henry Leland, that really highlighted just how risky these hand cranks were.
That's awful.
Yeah, it's a terrible story. And so Leland was determined to find a safer alternative. He turned to Charles Kettering, a brilliant inventor who developed the electric starter.
Oh,
It was revolutionary.
yeah.
Suddenly, cars were easier to start, more accessible to women drivers, and could accommodate much more powerful engines.
Right, but didn't those more powerful engines lead to a whole other set of problems?
You're thinking about engine knocking, right?
Yeah, exactly. Engine knocking.
Well, you are absolutely right. This new generation of powerful engines brought about a new problem, that knocking you were talking about.
Knocking.
So for those who maybe haven't heard that before, what is engine knocking?
So imagine you're driving along, everything is smooth, and then your engine starts making this horrible rattling, pinging sound. That's knocking. It happens when the fuel-air mixture in the engine's cylinders ignites prematurely, causing a sort of mini explosion that disrupts the smooth operation of the engine.
Oh, I think I have heard that sound before. It doesn't sound very good for the car.
It's not only is it an unpleasant sound, but it reduces engine power, wastes fuel, and it can even cause damage over time.
Oh, no.
So finding a solution to this knocking problem became a major focus for the automotive industry.
And this is where our friend Thomas Midgley Jr. enters the picture.
Yeah, Thomas Midgley Jr. Now there's a name that's going to come up a few times in this story.
Yes, he is quite a character.
Okay.
So Kettering, the inventor of the electric starter, now had this new challenge on his hands.
Right.
He tapped Midgley, one of his most talented engineers, to find a way to stop this annoying and potentially damaging knocking.
He seemed to have a knack for solving these kinds of problems.
He did. He was brilliant, relentless, and as we'll see, a bit too willing to overlook the potential consequences of his inventions.
Oh, this is where things start to get a little dicey, I suspect.
Yeah, this is where the story takes a bit of a darker turn.
So Midgley, he embarks on this quest to find this anti-knock additive, and his experiments were, well, let's just say he wasn't afraid to think outside the box.
Oh, I've heard stories about this guy. Didn't he try melting butter at one point?
He did, and camphor and all sorts of other things.
Wow.
Ethanol actually showed some promise, but it took way too much to be effective, about 10% of the fuel mixture.
Oh, wow. That's a lot.
It is a lot. He needed something that worked in tiny amounts.
Okay.
Then he stumbled upon tellurium, and it worked wonders.
Oh,
But there was one rather significant problem.
let me guess. It smelled awful.
You got it. The smell was so bad that Midgley himself described it as lingering for months.
Oh, no.
He even resorted to sleeping in the basement to escape the stench.
Oh, my goodness.
So clearly not a viable solution for mass production.
No, I can't imagine that going over well with consumers.
No, not at all.
So, back to square one for Midgley.
Back to the lab he went, determined to find that perfect solution. And in 1921, he discovered what he believed to be the answer.
Okay.
Tetraethyl, essentially lead with a few extra molecules attached.
Wait a minute. Lead, as in the lead we know is toxic.
That's right.
Oh, no.
And this is where the story takes a darker turn, despite early warnings from scientists about lead's toxicity.
Really?
Midgley and his team downplayed the dangers and marketed tetraethyl, which they cleverly branded as ethyl to avoid using the word lead,
Oh, wow.
as a miracle solution to engine knocking.
This is mind-boggling. They knew it was dangerous, but they pushed forward anyway?
Sadly, yes. The drive for profit and innovation often overshadowed concerns for public health back then.
It's a cautionary tale that unfortunately repeats itself throughout history.
It really is.
So while all this has happened, remember Clair Patterson is still back in his super clean lab, struggling to figure out why his Earth dating calculations are so off.
Exactly, and this is where the two stories collide. Patterson was one of the first to connect the dots between the widespread use of leaded gasoline and this mysterious lead contamination he was finding everywhere.
That's amazing.
His meticulous work in the lab, initially aimed at solving a purely scientific puzzle,
Right.
ended up having enormous implications for public health.
It's incredible how these two seemingly separate threads, dating the Earth and the development of lead and gasoline, are so intricately intertwined.
It really is.
But Patterson realized he needed to go beyond the lab to understand the true extent of this lead contamination. So he began by measuring lead levels in the oceans.
The ocean?
Yeah, hypothesizing that if lead were naturally occurring at high levels, it would be easily distributed throughout the water column.
Oh, okay, that makes sense.
But what he found was startling.
What did he discover?
The lead concentrations were much higher near the surface of the ocean compared to deeper depth.
Oh, wow.
This was a clear indication that the lead wasn't coming from natural sources deep within the Earth, but rather from recent pollution settling from the atmosphere.
So it was coming from us, essentially.
Yeah, exactly.
But how could he prove that this recent pollution was specifically linked to leaded gasoline?
That's a great question. To do that, he needed to go back in time.
Go back in time.
And he found a way to do just that
Right.
by analyzing ice cores from Greenland and Antarctica.
Ice cores. How do those work as time machines?
Well, think of ice cores like a layered cake, each layer representing a different period in Earth's history,
Okay.
as snow falls and compresses into ice over thousands of years.
Right.
It traps tiny air bubbles and particles from the atmosphere.
Okay.
Scientists can drill down through these layers, extracting these ancient air samples,
Wow.
and analyze them to track changes in atmospheric composition over time.
So what did Patterson's analysis of these ice cores reveal?
His findings were groundbreaking.
Okay.
They showed a dramatic spike in atmospheric lead levels starting in the 20th century, coinciding with the rise of leaded gasoline use.
So it all lined up.
It all lined up. It was undeniable evidence that human activity was directly responsible for this massive increase in lead contamination. And it wasn't just a local issue.
Right.
It was a global crisis.
Wow.
But if this lead was in the oceans, in the air, even trapped in ancient ice, where else was it ending up?
Oh, I think I know where you're going with this.
I have a bad feeling I know the answer to.
It was accumulating in our bodies, wasn't it?
You are absolutely right. Patterson's research compared lead levels in the bones and teeth of modern humans
Okay.
to those of ancient mummies.
Oh, wow. And what did he find?
The results were shocking. Modern humans had hundreds of times more lead in their systems compared to those ancient mummies.
Hundreds of times.
Hundreds of times. It was a stark and alarming illustration of just how much leaded gasoline had contaminated the environment and, consequently, our own bodies.
That's terrifying. We now know how dangerous lead exposure is, especially for children.
Right, it can cause developmental problems, learning disabilities, behavioral issues, and even lower IQs.
And what's even scarier is that there's no safe level of lead exposure. Even tiny amounts can have detrimental effects, especially on developing brains.
So Patterson's research was crucial in raising awareness about this hidden danger. It challenged the prevailing narrative that lead was a naturally occurring and therefore harmless part of the environment.
But it wasn't an easy battle, was it?
No, it wasn't. The lead industry, with its vast resources and influence,
Right.
fought tooth and nail to discredit Patterson's findings, claiming lead was harmless and naturally occurring.
Of course they did.
They used their power to try to silence him and protect their profits.
Wow, what a classic David versus Goliath situation. A lone scientist taking on powerful corporations to protect public health.
It really is. So what happened? Did Patterson manage to break through the industry's defenses?
He did. Patterson refused to back down. He continued publishing his research, speaking out at conferences, and challenging the lead industry's claims.
Good for him.
Slowly but surely, public opinion began to shift.
It's inspiring to see how one scientist's dedication to uncovering the truth can have such a profound impact.
It really is remarkable.
So, did we finally manage to kick our lead habit?
Eventually, yes. Thanks in large part to Patterson's tireless work, the U.S. finally banned leaded gasoline in 1996.
1996, that's not that long ago.
No, it's not, but it is considered one of the greatest public health victories of the 20th century.
That's a huge win for public health, but this whole story raises some uncomfortable questions.
Like what?
How can we let something so dangerous go on for so long? And are we doing enough today to identify and address other potential environmental threats?
It's a cautionary tale about the power of corporate influence,
Right?
the importance of independent scientific research, and the need for constant vigilance when it comes to protecting public health and the environment.
And the legacy of lead pollution continues, even though leaded gasoline is mostly a thing of the past.
Right.
Lead doesn't just disappear, it lingers in the soil, in old paint, and in our bodies.
That's right. The impact is multi-generational.
It is.
Children exposed to even low levels of lead can suffer lifelong consequences affecting their health, their intelligence, and even their chances of success in life.
It's a sobering reminder that our actions have far-reaching consequences, and sometimes the most brilliant innovations come with hidden costs.
They do.
But before we get too doom and gloom, let's shift gears a bit
Okay.
and talk about another one of Midgley's inventions.
Oh, there's more.
Oh yeah,
Okay.
I'm all ears.
It might surprise you.
You're talking about Freon, right?
Freon, yes.
The seemingly miraculous refrigerant that ended up causing a global environmental crisis.
Freon, the stuff that kept our food cold and, hair perfectly coiffed back in the day.
Right.
It's hard to believe that something so seemingly harmless could cause so much trouble. It really is a prime example of how even the best intentions can lead to these unintended consequences,
Right.
Like back in the early 20th century, refrigerators used some pretty toxic inflammable substances like ammonia and methyl chloride,
Oh, wow.
and accidents were pretty common.
Oh, no.
So there was a real need for a safer alternative.
So enter Thomas Midgley Jr. again, always the innovator.
Always up for a challenge.
Right.
So yeah, Midgley, who was working for General Motors at the time, took on the challenge, and in 1928, he synthesized dichlorodifluoromethane, which we all know better as Freon 12.
Freon 12.
It was non-toxic, non-flammable, and incredibly stable, seemingly the perfect solution.
And it took off like wildfire, didn't it? Refrigerators, air conditioners, aerosol cans. Freon was everywhere.
It revolutionized entire industries, but what we didn't realize at the time was that this wonder chemical, while perfectly safe at ground level, was slowly but surely wreaking havoc high up in the atmosphere, specifically the ozone layer.
The ozone layer. Now remind me what that does again?
It's essentially a protective shield that envelops our planet, absorbing most of the sun's harmful ultraviolet UV radiation.
Okay.
Without it, life on Earth as we know it would be impossible.
Right, right.
Yeah.
So how did Freon manage to mess that up?
Well, the very stability that made Freon so appealing, it doesn't break down easily,
Okay.
also meant that it could persist in the atmosphere for decades.
Oh, wow.
Over time, these Freon molecules would slowly drift up into the stratosphere where the ozone layer resides.
And then what happens?
Well, the intense UV radiation from the sun would break apart the Freon molecules,
Good.
releasing chlorine atoms.
Okay.
And unfortunately for us, chlorine acts like a Pac-Man for ozone molecules.
Oh, no.
One chlorine atom can destroy thousands of ozone molecules, leading to a depletion of this vital protective layer.
And this is what caused the ozone hole, right?
Exactly.
That was a huge global concern back in the 80s and 90s.
It was. Scientists discovered this massive depletion of ozone over Antarctica, and it was directly linked to the increasing concentration of CFCs in the atmosphere.
It was a wake-up call, wasn't it?
It was a stark realization that our technological advancements could have these unforeseen and potentially catastrophic consequences for the planet.
It's a very similar story to the lead situation.
It is.
Unintended consequences coming back to bite us.
Exactly. And thankfully, just like with leaded gasoline, we took action.
We did.
The Montreal Protocol, an international treaty signed in 1987, phased out the production and use of CFCs.
Okay.
It's considered one of the most successful environmental agreements in history.
That's encouraging, so the ozone layer is on the mend.
Slowly but surely, yes, it's expected to fully recover by the middle of the century, proving that we can solve these global environmental challenges when we work together.
That's really good news. It's fascinating and a bit ironic how Midgley set out to create this safer alternative to toxic refrigerants.
Right.
And ended up creating yet another global environmental crisis.
He was a brilliant chemist, but perhaps lacked the foresight to fully understand the long-term consequences of his inventions.
His story is a reminder that progress isn't always linear,
It's not.
and even the most well-intentioned innovations can have unforeseen and far-reaching impacts.
It's true, we have to be careful.
So Midgley created leaded gasoline, which contaminated the world, and Freon, which damaged the ozone layer. Did he ever realize the full extent of the damage his inventions had caused?
Unfortunately, no. In 1940, Midgley contracted polio, which left him partially paralyzed.
Wow.
He was only 51 when he died in 1944, and the circumstances surrounding his death are just as strange as the trajectory of his career.
Really? How so?
Well, Midgley, being the inventor he was, he devised this complex system of ropes and pulleys to help him move around in bed.
Oh, no.
Tragically, he became entangled in this contraption and accidentally strangled himself.
Wow, that's a truly unexpected and somewhat fitting end to such a complex and ultimately tragic story.
It is Thomas Midgley Jr., a man who sought to improve lives through innovation, left behind a legacy marked by both triumph and tragedy.
Yeah.
His story underscores the immense power of science to shape our world and the critical need for careful consideration of the long-term consequences of our technological advancements.
It's amazing what started as this deep dive into Clair Patterson's quest to date the Earth and ended up as this exploration of the unintended consequences of Midgley's inventions. But what strikes me most is just this interconnectedness of everything.
It's remarkable.
It's like pulling on one thread unravels this whole tapestry of scientific discovery and human ingenuity in this fragile balance of our planet.
It really highlights the fact that we live in a complex and interconnected world, and our actions, even those with the best intentions, can have ripple effects that extend far beyond our immediate understanding.
So next time you hop in your car, adjust your thermostat, or simply take a deep breath, and remember these stories.
Yeah.
They remind us to question, to think critically, and to consider the long-term impacts of our choices, both big and small.
It's through understanding these interconnected systems and acknowledging the potential consequences, both positive and negative, that we can truly harness the power of science and innovation to create a better, healthier, and more sustainable future for ourselves and for generations to come.
Absolutely. Well, that brings us to the end of this deep dive. Thanks for joining us on this journey through time, science, and the fascinating, sometimes unsettling legacy of human ingenuity.
It's been a pleasure.
Keep exploring, keep questioning, and until next time, keep diving deep.